My name is Molly Bradach, and I'm solving a problem in which we're solving for equilibrium partial pressure given initial partial pressure values and a Kp value. So the question we're looking at asks, considering the reaction in which bromine gas and chlorine gas are at equilibrium with bromine monochloride gas, and Kp equals 1.11 times 10 to the negative fourth at 150 K. A reaction mixture initially contains a bromine partial pressure of 755 torr and a chlorine partial pressure of 735 torr at 150 Kelvin. Calculate the equilibrium partial pressure of bromine monochloride. So when we break this down, we see that our given values are the balanced reaction and the partial pressure values initially of each gas. Bromine's initial partial pressure is 755 torr, chlorine's is 735 torr, and bromine monochloride's is 0 torr, considering it was not mentioned. Our Kp value is 1.11 times 10 to the negative fourth with no units at 150 Kelvin. And our goal is to calculate the equilibrium partial pressure of bromine monochloride. Because we're searching for the partial pressure value at equilibrium, and we're given initial partial pressure values and Kp, we're going to have to set up a Rice table to find the partial pressure values in terms of our x value representing change. So here's our Rice table set up with our balanced equation already figured out and our initial values that we are given. The partial pressures are all in terms of torr, but I will not be writing them throughout the math to keep it simpler. So our change for each value is what we must now figure out. For bromine and chlorine gases, our change is going to be negative x because they each have 1 mole active in the reaction. Our change for the bromine monochloride will be plus 2x as it is the product and there are 2 moles active in the reaction. Therefore, equilibrium partial pressures for bromine are going to be 755 minus x, for chlorine 735 minus x, and for bromine monochloride 2x because it will be the initial value on top of the change that is occurring. Next, we will look at our Kp equation using the law of mass action. On its own, this has each of the products raised to their coefficients multiplied by each other, divided by each of the reactants raised to their coefficients multiplied by each other. When we put in our particular reaction, this is what we get. Partial pressure of bromine monochloride squared over bromine's partial pressure times chlorine's partial pressure, and we're provided the Kp value, which this is equal to. When we plug in our equilibrium values from our Rice table into the Kp equation, what we will get is that 2x squared, which is the partial pressure for bromine monochloride, is equal to 755 is divided by 755 minus x times 735 minus x, which are the partial pressures for bromine and chlorine at equilibrium. Now, when we square our 2x and then FOIL and rearrange our values, we will get that 1.11 times 10 to the negative fourth, our Kp value, is equal to 4x squared divided by x squared minus 1,490x plus 554,925. We can cross multiply in order to get rid of our denominators and then set equal to 0 by subtracting 4x squared from the left side. And now we have an equation that is set equal to 0 and can be used with the quadratic formula in order to solve for x. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When we plug in our values that we found from our equation, we get x equals 0.165 plus or minus the square root of negative 0.165 squared minus 4 times negative 4 times 61.597 all over 2 times 4, which ultimately, when simplified, gives us 0.165 plus or minus 31.394 divided by 8. Now, with the quadratic formula, we can now add or subtract the 31.394 in the math to give two different x values. Now, if we add x, or if we add, our x value will be 3.945, whereas if we subtract, our x will be negative 3.904. We cannot have a negative value for the change occurring, so therefore we know that our x value being used will be 3.945. Now, if we go back to our Rice table, we see that our equilibrium partial pressure for bromine monochloride is 2x, and that is the value we're solving for. So now that we have x, we are able to plug in the x value we have times 2, and what we get for the partial pressure at equilibrium for bromine monochloride is 7.89 torr. It's in torr, as those are the partial pressure units we've been given, and it has 3 significant figures. In conclusion, this problem asked us to find the equilibrium partial pressure of bromine monochloride in a given reaction, provided initial partial pressures as well as Kp. The Rice table got us to the equilibrium partial pressures in terms of x, which was the change in partial pressure, and the law of mass action allowed us to set our Kp value equal to the partial pressures at equilibrium. We then used the quadratic formula to solve for x, and use the appropriate x value in the equilibrium partial pressure for bromine monochloride to calculate its actual value, which was 7.89 torr.